Alright, so let's take a look at how to add and subtract radicals. So what I would like to do is refer to what we have learned earlier with variables. So if you think about variables, and I think everybody's comfortable with adding and subtracting variables, if I give you a question like this, you know that in this case, you take the coefficients, 3 and 2, and you say it is 5x. Like 3 apples plus 2 apples is 5 apples, so x stands for something. However, if I were to give you two different variables, x and y, this will not combine. It will not add or subtract if this was a subtraction question, because the rule in the variables is that you have to have the same variables. So this you can't do anything and it will stay as 3x plus 2y. It's like 2 apples and 3 apples and 2 bananas. Can't do anything with it. Also, if I give you same variables, but their degree is different. So 3 is just with an x, is a coefficient of x, and 2 is a coefficient of x squared. In this case, you still can't combine them because they're different degrees. So it will stay as 3x plus 2x squared. So in variables, we say you have to have the same variable, and also you have to have the same degree. So if I wanted to add something with a second degree, both of them have to be the same degree. Then only can I combine their coefficients. So these are called like terms. We use that a lot in previous math, combining like terms. Same rule applies in radical. Okay, in radical, if you have, let's say 3 root 5 plus 2 root 5, this kind of acts like its degree, the index. So the index here is 2, and the index here is 2, and these act like the actual variables. You don't actually combine them. Just like in here, x and x just stay as x. They are means of collecting it. You only combine their coefficients. Same thing will happen here. So we don't touch the variable. We don't touch the radicand. It will stay as it is. Okay, so we only combine the coefficients. Now, if you have a different radicand, like this, it will not combine, because in this case, again, we need the same index and the same radicand. So same thing like you did here, if it was x and y, you couldn't combine them. Root 5 and root 7 are two different radicands, you cannot combine them. So what happens if you have the same radicand, but a different index? Think about what happened here when you had the same variable, but a different degree. Here we have the same radicand, but different index. That's still a no-no. So remember I said it has to be the same index. It kind of acts like the degree. And it has to be the same radicand, acts like the variable. And then you can only combine the coefficients. Same like you did here. So that's the rule to adding and subtracting radicands. Okay, radicals. Now, that's the objective of this lesson. So you'll see in this first one, that's what they're trying to get us to show. If you have two same index and same radicand, then the coefficients, there's an invisible one, will combine. In this case, again, same radicand, same index, so coefficients will do their thing, whatever the signs are telling us to do. 9 minus 4 is 5, 5 minus 4 is 1. You want to write the 1, it's fine, or you can just simply write root 3. When you have a bunch of different radicands, but the index are same. So you'll say, okay, these two will combine because they have the same radicand and the same index. So the signs are telling us to add them. And then these two will also combine because they also follow the rule. Their signs are also telling us to add them, but the answer will be negative, and that becomes our answer. It doesn't matter whether you write -8 root 5 first and then the 6, because in addition, it doesn't matter the order. Okay, so this example, remember there's always an invisible 1 in front of everything. And then if you have a bunch of different radicands or indexes, pick the like terms and only combine their coefficients. Okay.